Hello students, welcome to my channel. So today we'll be discussing topic friction. Let us start quickly. So in today's topic we'll be defining what is friction and what are the factors affecting friction and what are different types of friction, and we'll be discussing about angle of friction and angle of repose. So let us start with what is friction. So, in class 8, you have learnt what is friction. That is, friction comes into play when two objects tends to move or actually moving with respect to each other. Suppose this is one body, this is another body. So, this body is on the other body, and when it is trying to move or when it is actually moving, then friction comes into play. Okay, so for friction to come into play, there should be two bodies. They should be in contact with each other because frictional force is a contact force, and they should try to move or moving with respect to each other. So there is a question. So if a block is at rest on a table, will frictional force act on the block? So they are saying there is a block which is just lying on a surface at rest. Okay, so will friction act on it? So from the definition, what does it say? If the body tends to move or actually moving with respect to each other, is any of the case happening? If the block is just lying on another surface, is it tending to move? No, it is at rest. Is it moving? Obviously no, it is at rest. So friction is not acting. So will frictional force act on the block? No. No is the answer. Frictional force doesn't act on a block which is at rest on a surface. Okay, on a horizontal surface in this particular case. Right, next. Does frictional force oppose motion? So many of the students have this misconception that friction opposes motion. Actually, it is a wrong assumption or wrong understanding, because if this block is there, I'm keeping on my hand, and when I'm moving my hand, even the block is moving along with my hand. So how is it possible? Which force is making the block move? Actually, it is friction only. Because of friction, that block is moving. Or else, if you want, I can draw and show. Suppose this is a surface. There is a block A, and there is another block B, and I am exerting force on block A, and I am trying to pull the block. And both the blocks are moving in the direction of exertion of force. So in that particular case, which force is making this B move? Which force is acting on B? Obviously friction. So saying friction opposes motion is a wrong statement. Friction supports motion also. Even we are able to walk on a surface because of friction. Even your vehicle is able to accelerate on a surface because of friction. So saying friction opposes motion is a blunder. Okay, friction all the cases it doesn't oppose motion. Okay, then how do I say that statement? I have to say friction opposes relative motion. So let us try to understand what is this with an example. So when force acts on the bottom block, so previously we were talking a case where there are two blocks, one above another, block A and block B, and a force is being exerted on A such that both the blocks are moving in the same direction. So in this case, let us try to understand that or justify that statement: friction opposes relative motion. Okay, so in case if there is no friction between A and B, how should be the case? I'm only exerting force on A. So only A should be moving forward and B should be there itself at rest. Correct? If there is no friction. In case if there is no friction, B should be there itself and A should be moving forward. So in that case, relative motion of A as seen by B, like if you are sitting on that B and in front of you A is moving forward. So how do you see motion of A? Obviously in the forward direction. So relative motion of A as seen by B is forward. Okay, is forward. So friction opposes relative motion. So on A, friction should act in backward direction. Okay, as friction opposes relative motion of A as seen by B is forward. So friction acts in backward direction. Now let us talk about friction acting on B. So as seen by A, what will be the relative motion of B? Suppose you are on a bus moving forward and there is a stationary tree. How do you see the tree? You see the tree moving backwards. This is our general experience when you are traveling in a car or a bike or a bicycle or a bus or a train. So as you are moving forward and there is a stationary tree, you see the tree as if it is moving backward. Now relative motion of B as seen by A will be backward. So friction on B should act in forward direction. So you have to understand this, that force exists in pairs, action reaction pair. So here also action reaction pair of friction will be acting on B and A blocks. If A on A if it is backwards, then on B it will be obviously forward. Okay, action reaction pair. So you have to understand this relative motion of A as seen by B is forward and relative motion of B as seen by A is backward. So friction opposes relative motion. So relative motion of A is forward. So friction acts in backward direction for A and relative motion of B as seen by A is backward. So friction acts in forward direction for block B. Okay, understood. That is the reason as friction is acting on B in forward direction, B is also moving forward and friction on A will be acting in backward direction, action reaction pair. Okay, I hope you understood. Let us try to what I should say, use the same on the next example. When force acts on the top block, so in this case force was acting on the bottom block. So let us do this. So this is the surface. So there is block A on the bottom surface and block B on top of A, and now I am exerting a force on the top block. Now what will happen if there is no friction between A and B? A should be there itself and B should be moving forward, right? If there is no friction, A should be there itself and B should be moving forward. So now relative motion of B as seen by A is forward only. So relative motion of B as seen by A is forward. So what should be the direction of friction? Friction opposes relative motion, right? So friction should act in backward direction on B. Means like this. On B, friction will be acting in backward direction. Like this. Then, relative motion of A as seen by B. Relative motion. Sorry, I missed motion previously. Term motion. Relative motion of A as seen by B will be, so B is moving forward. Same that bus and tree example. If bus is moving forward, it sees the stationary tree as if it is moving backward. So here also A will see as if B is moving backwards. So on it, friction should act in obviously forward direction because friction opposes relative motion. So friction on A will be acting in forward direction. So action reaction pair satisfied, and you can see this also as friction is acting on A. Because of friction, A is moving forward. B is moving forward because you are exerting a force, external force. But A will move forward because there is some friction acting on it in that direction. So if you see here, for A, friction is supporting motion, and for B, friction is opposing motion. So saying friction opposes motion is a wrong statement. Like in general, if you say friction opposes motion, that's a wrong statement. When two surfaces are there and they're tending to move, it will oppose one surface movement and it will be supporting another surface movement because it will be acting in both the directions. Okay, so I hope you understood. So friction opposes relative motion, and friction comes into play when two bodies tends to move or actually moving with respect to each other. Okay, next. So factors affecting friction. So nature of surface. So if two surfaces are rough, then there will be greater friction. If two surfaces are smooth, then friction will be lesser. So it depends on the nature of surface. Okay, in class 8 also you would have learned because of the irregularities, interlocking of irregularities of the surfaces, friction will be acting. So greater the irregularities, greater the friction. Okay, then normal reaction. So friction depends on normal reaction. Greater the normal reaction, greater the friction, that we'll see in the coming topics. Then area of contact. So friction is independent of area of contact. Suppose this is a block. So whether this block is moving like this or like this or like this, in all the three cases the friction acting will be same because friction is independent of area of contact. It just depends on the normal reaction, it depends on the nature of the surface. So whether the block is like this or like this or like this, the nature of surfaces are same and even the normal reaction is same. So friction will be same in all three cases. So friction is independent of area of contact. Okay, next. So types of friction. So static friction, kinetic friction, also called as dynamic or sliding friction, then rolling friction. Let us see one by one. So static friction. So when a body is tending to move with respect to the surface of another body, then static friction comes into play. Means it's not moving, static, rest. It is at rest and it is trying to move. So I have given this example of a man pushing a bus. So obviously a single person may not be able to push a bus. Suppose all of you are going to a picnic and suddenly some issue came with the bus engine and the driver requested you people to push the bus. So say first a single person went and started pushing and the bus didn't move. Okay, then who is negating the force applied by that single person? That will be static friction because the bus is tending to move. Like suppose this block is there at rest, its mass is m, and there is a force acting on it, and it is at rest. Means there is some opposing force is there. Obviously, as it is at rest, that should be static friction. It will be denoted with F suffix small s. Okay. So static friction is self-adjusting in nature. Suppose instead of F, now I applied 2F force. Still the block is not moving. Initially when F force was applied and block is not moving, then the static friction value is also equal to F, because it is at rest, it is in equilibrium, means net force is 0. Now 2F is applied, still the block is at rest, means now the static friction value is 2F. Now say I exerted 3F, still it is at rest, then static friction is 3F. Now I applied 10F and the block is about to move. Even if I exert a little more force, the block will start moving. That means that is the maximum value of static friction, 10F, in this particular example. So like that, that maximum value of static friction is called as limiting friction. Okay, first of all, I hope you understood this, that static friction is self-adjusting in nature. Okay, then the maximum value of static friction is called as limiting friction. The maximum value of static friction is called as limiting friction. Okay, when the object is about to move, then that maximum value of static friction is called as limiting friction, and usually this limiting friction value is directly proportional to the normal reaction, and the proportionality constant is denoted with mu suffix s. Okay, that mu suffix s is called as coefficient of static friction. Coefficient of static friction. And it depends on the nature of surface. Both the surfaces, whichever bodies are in contact, it depends on those nature of those surfaces. Usually its value will be less than 1. Okay, so limiting friction value is directly proportional to normal reaction, and the proportionality constant is mu suffix s, called as coefficient of static friction. So you can write the formula as shown, that limiting friction F suffix L is equal to mu suffix s times of normal reaction. Okay, right? I hope you're following. Next, so kinetic friction. So when two bodies are actually moving with respect to each other, previously the body was tending to move but it was at rest. Now when we are discussing about the limiting friction, that is the maximum value of static friction. If I exert force above that, the bodies will start moving with respect to each other. When two bodies start moving with respect to each other, the friction acting between them is called as kinetic friction. And even kinetic friction is proportional, directly proportional to the normal reaction, and the proportionality constant is mu suffix k, which is coefficient of kinetic friction. Mu suffix k is coefficient of kinetic friction. Okay, so you may be thinking, what's the difference between that limiting friction and kinetic friction, or like the formulae, what is the difference is mu k and mu suffixes, they both are different for two surfaces. Usually mu suffix s will be greater than mu suffix k. Okay, you would have observed this when you are trying to push a body and it is at rest, you have to exert greater force, but once it starts moving, you don't need to exert that much force as you are trying to push it. The reason is, here itself you have seen, as mu suffix s is greater than mu suffix k, limiting friction value will be greater than kinetic friction. Okay, as limiting friction is greater than kinetic friction, to bring the body into motion, you have to exert greater force. But once it is in motion, as kinetic friction value is less, you need to exert lesser force to maintain its motion. Okay, that's why they say it's this statement: it is difficult to bring a body into motion than to maintain it. Okay, you need to exert greater force to bring a body into motion than maintaining its motion, because limiting friction value is greater than kinetic friction value. Okay, I hope you're following. Next one. So you can see this graph of frictional force but and applied force. Okay, let me just quickly change the color. Right, so you can see this particular region where the graph is a straight line passing through origin with 45-degree angle. The reason being, limiting friction, or I mean sorry, static friction is equal to the applied force. Whatever value you exert, that much value will be the static friction value, because it is self-adjusting in nature. So it should follow the straight line y equal to x. So it is a straight line passing through origin with 45 degrees angle. So this is when body is at rest. Okay, and this maximum value of static friction is nothing but limiting friction. Maximum value of static friction is nothing but limiting friction value. In this particular case, it is 3 Newton. Okay, and once you brought the body into motion, from here onwards, body is in motion. The force which you have to exert is just of kinetic friction. Sorry, this is wrong. Kinetic friction you have to exert. Okay, and you can see kinetic friction is less than limiting friction, and unlike limiting friction, which is self-adjusting in nature, kinetic friction is more or less a constant value. Okay, kinetic friction is constant, but static friction is self-adjusting. It depends on the applied force. Okay, I hope you're for understanding. Next, rolling friction. So rolling friction comes into play when body tends to roll or actually rolling with respect to another body, and rolling friction depends on area of contact. Best example, when your vehicle's tire gets punctured, especially bicycle if you are riding, and if its tire is getting punctured, then greater area is in contact with road, then you find it difficult to pedal the cycle. You have to exert greater force. But when the tires are filled with air, then the area of contact with ground will be less. Then it will be easy for you to pedal the bicycle. Okay, so rolling friction depends on area of contact. If area of contact is less, then frictional force is less. Okay, and among all the types of friction, rolling friction is having the least value. Maximum is limiting friction, next is kinetic friction, and least is rolling friction. Okay, so that is the reason, if you want to reduce friction, instead of sliding, if you convert it to rolling, that means also you have reduced the friction. That's why all our luggage bags, you just don't drag on the surface, you just fix wheels to it. Means instead of sliding friction, you converted it into rolling friction, which is a lesser value, so it will be easy for you to pull. Okay, so rolling friction is least, maximum is limiting friction, next is kinetic friction, least is rolling friction. Okay, then angle of friction. So suppose there is this, okay, sorry, let me change the color quickly. Right, so suppose there is a block of mass M lying on a surface. Now I am exerting an external force. Okay, and it is at its maximum value of static friction, and it is at rest. So if I draw its free body diagram, its weight is acting downward, normal reaction is acting upward. Okay, and friction will be acting in backward direction, limiting friction, which will be mu s times of normal reaction. And here in this case, if you see, normal reaction is equal to weight. Okay, so there are two types of contact forces acting on the block. One is friction in backward direction, one is normal reaction exerted by the surface in upward direction. So if anyone asks what is the net contact force, that is the resultant of limiting friction and normal reaction, which will be acting in this direction. It is net contact force. Okay, so that net contact force will be resultant of normal reaction and friction, that limiting friction value. So the angle between this normal reaction and the net contact force, this is called as angle of friction. Okay, the angle between normal reaction and the resultant contact force is called as angle of friction. Okay, so in this triangle, if I close this with limiting friction, then if I need tan theta, in the triangle tan theta will be limiting friction divided by normal reaction, and limiting friction is mu times of normal reaction divided by normal reaction. So mu suffix is, okay, mu suffix is, so tan theta is mu suffix s, or theta is tan inverse of mu suffix s. That is a formula of angle of friction, tan inverse of mu suffix s. So angle of friction is the angle between normal reaction and net contact force. It is also called as limiting angle of friction. Okay, next. Angle of repose, the angle at which the block kept on an inclined plane starts sliding. So now a block is kept on an inclined plane of inclination theta. A block of mass m. Now the maximum angle at which the block is at rest, like what I should say, suppose this is the plane on which I have kept a block, and slowly I started rising the inclination. There is some particular angle at which the block will start sliding, as you can see. Okay, so the maximum angle at which the block is at rest, or the minimum angle at which the block starts sliding, that is called as angle of repose. I'll repeat again. The maximum angle at which the block is at rest, or the minimum angle at which the block starts sliding, that angle is called as angle of repose. So in this particular case, as it is maximum angle, there will be limiting friction acting. Weight, if I resolve into components, this will be mg cos theta, this will be mg sin theta along the inclined plane, and there will be normal reaction acting. Okay, so as it is at rest at that maximum angle, limiting friction value should be mg sin theta, and normal reaction value should be mg cos theta, and limiting friction value again should be equal to mu suffix s times of normal reaction. So if I divide both mg sin theta by mg cos theta, that is equal to, limiting friction is mu s times of normal reaction divided by normal reaction, cancel. So tan theta is equal to mu s, or theta, which is angle of repose, is tan inverse of coefficient of static friction. So you got formula similar to angle of friction. So angle of repose is the angle at which the block kept on inclined plane starts sliding. that particular angle is called as angle of repose. Okay, students. So today, what all things we have discussed? What is friction? What is friction? It is a force that comes into play when two bodies tends to move or actually move with respect to each other. Okay, and what else we have discussed? And friction opposes relative motion. That discussion we have done with block on block example. Then factors affecting friction. Friction depends on nature of surface, whether rough or smooth. Then normal reaction, it's directly proportional to normal reaction. You have seen in the case of limiting friction and kinetic friction. And friction is independent of area of contact if it is static or kinetic friction. If it is rolling friction, it depends on area of contact. Then types of friction: static, kinetic, rolling. We have seen static friction is self-adjusting in nature. It is a force which acts when body is at rest and tending to move. And the maximum value of static friction is called as limiting friction. And static friction is directly proportional to normal reaction, and the formula is given by limiting friction is directly proportional to normal reaction, and the formula is given by FL is equal to mu s times of n. Then kinetic friction comes into play when body tends to move. No, actually moving. If it is tending to move, then that is static friction. If it is actually moving with respect to another surface, then the friction acting is kinetic friction. And kinetic friction is also directly proportional to normal reaction, but the proportionality constant here is coefficient of kinetic friction, mu suffix k, which is less than mu suffix s. That's why kinetic friction is less than limiting friction, and kinetic friction is more or less constant. Then rolling friction, that comes into play when body is rolling or tending to roll with respect to another surface, and rolling friction depends on area of contact. We have discussed that. And rolling friction is having the least magnitude among all the types of friction, and limiting friction is having maximum magnitude. Then angle of friction, it is the angle between the normal reaction and resultant contact force, and it's also called as limiting angle of friction, and the formula we have seen, it is tan inverse of mu suffix s. And angle of repose, angle at which the block kept on an inclined plane starts sliding. Okay, and its formula is also tan inverse of mu s. Okay, that's all for today, students. Thank you so much. Okay, and if you have any doubts, do post in the comment section. I'll be replying. Do like the video and subscribe to my channel and click on the bell icon for very interesting videos. Okay, thank you.